Alright guys, this is the video lesson for 11-2, operations with radical expressions. I think you're going to actually like this section because if you understand how to do operations with variables, operations with radicals is pretty much the exact same. So a little review here on how to do operations with radicals, and in this case I'm just going to say right here we're combining like terms. So, how do you take 2x plus 7x? Well, they're like terms. You just add them together and you get 9x. 2x's plus 7x's is 9x's. Over here on number 2, 12x plus 3y plus 6y minus 8x. Again, combine like terms. 12x minus 8x gives you 4x. And 3y plus 6y gives you positive 9y. I cannot combine those two because they are not like terms. So you're simply combining like terms. That's what we're going to do here with radicals. You can think of the radicals as like terms, or think of the square root part, the radical part, just like you would with variables. So in problem number 1, if I have 2 root 11 plus 7 root 11, you're going to get 9 root 11. 2 plus 7 is 9, so you have 9 root 11s done, because obviously the square root of 11 cannot be simplified. Now, remember, always check for simplification if you can. 11 cannot be simplified, so I'm done. Problem number 2 here, again, just like above, 12 root 5 plus 3 root 7 plus 3 root 7 plus or minus 8 root 5, you're going to combine like terms. 12 root 5 minus 8 root 5 is 4 root 5. And then 3 root 7 plus another 3 root 7 gives you 6 root 7s. And now you cannot add these two together because they are not like terms. You have 4 root 5s plus 6 root 7s, not like terms. You're done. Again, you're done as long as the root 5 and the root 7 cannot be simplified like we did in the last section in 11-1 when we were simplifying radicals again. So, pretty simple stuff here. You should really try number 3 and 4 then on your own by pausing the video, and then check your answers when you're done. Alright, so here we go. 6 root 5 plus 2 root 5 minus 5 root 5. I might do this in stages here. 6 root 5 plus 2 root 5 is 8 root 5 minus 5 root 5 gives me 3 root 5. Done. Number 4. 7 root 2 minus 6 root 2 is 1 root 2. Do you have to write that 1 there? No. So you could just say root 2. 1 root 2 is just root 2. And then 8 root 11 minus 4 root 11 is a positive 4 root 11. And again, we're done simply because none of the radicals can be simplified. These were all already simplified radicals: root 11, root 2, root 5, root 7. Okay, so pretty simple so far. Let's move down now into some problems where maybe you do need to simplify some radicals. Okay, so looking at number 5 here, you might first look here and say, well, there are no like terms, and that is correct. 6 root 27 is not a like term with 8 root 12 and 2 root 75. None of those are like terms. So you might say, well, there's nothing I can combine. And that would be correct if these radicals didn't simplify. If these radicals didn't simplify, yeah, maybe you're done right here. This is as simplified as it gets. But these radicals will obviously simplify, so that's what we need to do. We need to break down square root of 27. I'm going to say 3 times 9. Circle my 3. 9 is 3 times 3. So again, this is just a review of the last section. I have a pair of 3's here that comes out in the front as a 3. 3 times 6 then is 18. And what's left underneath the radical is that extra 3 that had no pair. So 18 root 3 is my first term. My second term, I have to break down the square root of 12. So 2 times 6. 6 is 2 times 3. So in this case, I have a pair of 2's coming out in the front as a 2, making 2 times 8, positive 16, and then underneath the radical was this leftover root 3. And now I break down 2 root 75. 75 breaks down into, well, let's go with 3 and 25. 25 is 5 and 5. So I have a pair of 5's that comes out in the front as a 5, making 5 times 2, 10. And then again, I have this leftover 3 as a root 3. Now, notice in this case, I simplified all 3 of my terms, and now all 3 of them are like terms because they are all root 3's. So what's 18 root 3 plus 16 root 3 plus 10 root 3? You get a total of 44 root 3's. Done. So again, an extra step to this pretty basic section is that you first need to simplify if simplification is possible. After you simplify, look for combining like terms. And again, this is all really a review of what we did with variables way back in the early chapters. So really, again, you should try number 6 here on your own, and then unpause the video and check your answer. Alright, number 6, I'm going to start out here by simplifying the square root of 20. 2 times 10. 10 is 2 times 5. This pair of 2's comes out front as a 2, and it gets multiplied with that 2 that was already out there, and we get 4 root 5, because the 5 was the only thing left over on the inside. Square root of 45, I'm going to use 9 times 5. Oh, don't circle that. Circle 5. 9 is 3 times 3. So again, a pair of 3's comes out front as a 3. Gets multiplied with the 3 that was already out there, giving me 9 root 5. Again, because the root 5 is the only thing left. Square root of 180. Let's break this down. Let's do 18 and 10. 18 is 9 and 2. 9 is 3 and 3. 10 is 2 and 5. So where are my pairs here? Pair of 3's comes out front as a 3. Pair of 2's comes out front as a 2. 3 times 2 gives me 6. And then root 5 is left over. So once again, none of them looked like they were like terms. They all actually are. 4 root 5 plus 9 root 5 plus 6 root 5 gives me 19 root 5's. Alright, 7 and 8, a little bit more difficult because of the fractions and because of the fact that we have to rationalize our denominators here. Again, something that we learned in the last section, rationalizing denominators. So let's just start out here. I'm going to turn this square root of 2 into the square root of 2 over 1 so that I have both things being fractions. And I'm going to turn this square root of 1 over 2 into a fraction where the numerator is the square root of 1 and the denominator is the square root of 2. Now, be careful here and do not think that you're going to cross cancel the square root of 2's, because you can only cross cancel when we multiply fractions together. So definitely do not cross cancel here. We are adding fractions together. So remembering that we want common denominators here, and remembering that this second fraction has a denominator of a 2, or a square root denominator that can't be left like that. So we're going to rationalize this denominator by multiplying top and bottom by the square root of 2. Now, you might look up here at the top and say, well, the square root of 1 is just 1, and I'm just going to use my eraser here. Square root of 1 is just 1, so I'm just going to change that into the whole number 1. Make it a little bit easier when I multiply top and bottom by the square root of 2. So what I now have, excuse me, I got choked up. What I have here is the square root of 2 over 1 plus the square root of 2 over 2. Again, because square root of 2 times square root of 2 is the square root of 4, and the square root of 4 is 2. Again, that's all review from 11-1. So now I'm close, because I have two fractions where the denominators are not radicals. They're whole numbers, 1 and 2, which is good. But again, in order to add fractions together, you have to have a common denominator. So how do I get a common denominator here? Well, if this one's a 1 and this one's a 2, I'm going to just multiply this first fraction, multiply the numerator and the denominator by 2, turning my first fraction now into 2 root 2 over 2, a lot of 2's there, plus the square root of 2 over 2. And now don't cancel anything yet, because you did this so that you can add them together. 2 root 2 plus 1 root 2 gives me 3 root 2. And a common denominator, remember when you're adding fractions, denominators don't change, so the common denominator of 2 gives us our final answer here, 3 root 2 over 2. So again, we're kind of assuming you know how to deal with fractions at least a little bit, how to add and subtract fractions together. So let's go ahead and do number 8, or go ahead and try number 8 on your own possibly. I'm going to pretty much go through the same process here. Square root of 10 over 1 minus the square root of 2 over the square root of 5. To rationalize this second fraction, I'm going to multiply by the square root of 5 on the top and the bottom. Square root of 10 over 1 minus square root of 10 over 5. Again, because root 2 times root 5 is how I got the root 10. Root 5 times root 5, yes, is root 25, but that turns into whole number 5. So really none of that work needs to be shown if you understand that. I have two fractions now. They do not yet have a common denominator, but they do have whole numbers in the denominator, which is good. So to make this a common denominator, I'm going to multiply this first fraction, top and bottom, numerator and denominator, by 5. Meaning I now have 5 root 10 over 5 minus 1 root 10 over 5. And again, simplifying fractions. 5 root 10 minus 1 root 10 is 4 root 10. And common denominator is 5. Again, does the square root of 10 reduce? No. But if it did, would you? Yes. But it doesn't, so you're just done. 4 root 10 over 5. Okay, again, adding a story problem into this type of work, but again, these story problems are pretty simple because the math is pretty simple. It says, find the perimeter of a rectangle whose length is 8 root 7 plus 4 root 5 inches, and whose width is 5 root 7 minus 3 root 5. Well, a couple things you got to remember here is, what does a rectangle look like? There we go. If the length is 8 root 7 plus 4 root 5, and the width is 5 root 7 minus 3 root 5. And you need to know how to find the perimeter of something. Well, the perimeter is to add up all four sides. Now, you might say, well, can I multiply the length by 2, multiply the width by 2, and then add that together? And yes, you can, except we haven't taught you how to multiply radicals together yet. At least not radicals where there might be some distributing taking place. You know how to multiply radicals, but maybe not with distributing. So let's just do this with addition and subtraction. The length is 8 root 7 plus 4 root 5, and there's going to be two lengths, right? So I'm going to add another 8 root 7 plus 4 root 5, and then you're going to add the width, which is 5 root 7 minus 3 root 5, and you're going to add another width of 5 root 7 minus 3 root 5. And now you're just going to combine all of your like terms. I have 8 root 7 plus 8 root 7, which is 16 root 7, plus 5 root 7 plus 5 root 7 gives me a total of 26 root 7. Then I combine my root 5s. 4 root 5 plus 4 root 5 is 8 root 5 minus 3 root 5 minus 3 root 5. So I end up with positive 2 root 5. And this is a story problem, so you should say the perimeter is 26 root 7. I don't know what that extra mark in there, where that came from. Let me just rewrite that. 26 root 7 plus 2 root 5 inches. Done. All right, not too bad. Hopefully that was pretty easy. This is what we're going to call part 1. Part 2 is really no more difficult than part 1. It's just we're going to do multiplication work now. Multiplication, whereas in this section we just did adding and subtracting. So we'll call that part 1 and go ahead and move on to part 2 and learn how to multiply these things together.